really minimal requirement for something to put a human through. You need about -1 Jupiter's worth of this exotic matter.
Ordinary matter, like armchairs, has positive energy. So you might think that needing exotic matter, stuff with negative energy, would rule out a realistic time machine. But in fact, that's not the case. In a lab in Seattle, Steve Lamoureux has shown that negative energy can be made.
You can see here there's a tungsten wire. Comes down
Matt Visser is a theoretical expert on negative energy, but he's never seen it for real. Negative energy is made by squeezing energy out of a vacuum that they create in a tiny gap between two plates.
That experiment, from our point of view, is a proof in principle that at least small amounts of exotic matter, effectively negative energy, do exist in the real world.
So negative energy is real. In the future, an infinitely advanced time tourist might be able to make enough of it to stretch a wormhole big enough and hold it open long enough to make a safe journey into the past. With negative energy real in practice and wormholes real in theory, Thorne took the plunge and went public.
My concern was the word time machine in the title, and my worry was that the popular press would see this paper and would start to ballyhoo it in a manner that caused our serious scientific colleagues to pay no attention to it as being crackpot stuff. Very quickly, the rest of the press grabbed hold of it. Here we are, we've invented time travel. There were other stories that basically had us building time machines in our own basements. And I rather quickly pulled back and told the Caltech Public Relations Office, I do not give interviews on this subject. I told my research group's administrative assistant, I do not return telephone calls from the press on this subject. I will talk about anything else but not time travel.
But Thorne's work brought other scientists out into the open.
When I realized that my friend and extremely great scientist, Kip Thorne, published it, I immediately called him and told, thank you so much for that. Now I will publish, I will work on this subject also.
He was overjoyed. On the other end of the phone, he said, oh, Kip, it's absolutely wonderful. Your paper's wonderful. You've broken the barrier. If you can do research about time travel, then so can I.
Igor Novikov had been working on time travel in secret for years. He was interested in the trouble that time travelers might cause if they went back and tried to change history.
Once it appeared that time machines were a real possibility, we then had to face the question of paradoxes, of going back in time and changing history, and thereby causing the foundations of physics to crumble beneath us.
The grandfather paradox is a very simple science fiction-based apparent inconsistency at the very heart of the idea of backwards time travel.
That cannonball that knocked my grandfather unconscious in the Civil War battle, so he lay there 3 days before he came back. Suppose that I had deflected the cannon slightly and he had really been killed.
Where does that then leave you?
How do I get here?
Do you instantly pop out of existence because you were never made?
But then you couldn't have gone back, and so on.
Then could it be self-consistent? Novikov approached the equations from all angles, and every time only the self-consistent solutions worked out.
This is the main principle. All these events must be in self-consistency with each other. It's so simple, so obvious, but more of that. We gave the strict mathematical proof that this principle is the consequence of the basic ideas of the physics.
By the same token, any attempt a time traveller might make to rewrite history would be thwarted.
Yes?
I'm here to prepare your room, mein Herr.
What has happened has happened. It cannot be changed. It cannot be repeated twice in different ways.
Human beings aren't billiard balls, and we might like to believe in free will. So a sufficiently stubborn human would seem to be able to get around any sort of consistency condition by just demanding that he does something different.
I can have a free will to walk along this wall without special equipment. It's my free will. Can I do that? No, I can't. Why? Because of a law of physics, because of the law of gravity. It's forbidden.
Gravity means you can't walk up a wall, so gravity already restrains our free will. And if time travel ever does become possible, other laws of physics would stop a traveller from changing the past.
Driscoll, open up, please. Immediately.
Immediately now at this door. Will you open up this door? Immediately.
Those determined to change history might try to send a message backwards in time. But to do that, we'd have to send information faster than light. And this man reckons he can send a signal faster than light into the realm where Einstein said time would run backwards.
This signal is split into, by an electronic mirror here, into two parts. So we can compare the signal. One is moving through the air and the other one is moving through the barrier.
Gunter Nimtz splits a microwave signal. The half that goes through the air travels at the speed of light and is displayed on an oscilloscope. The half that hits the barrier should go nowhere, but that's not what seems to happen.
This is an oscilloscope where you see the signal and then we can see which one is faster.
The two humps on the screen are not in the same place because one signal got there faster than the other, and the faster one tunneled through the barrier.
Only a very small part comes to the other side. But it comes, and this part comes at a velocity which is much faster than the velocity of light.
Nimtz believes that the faster signal uses a strange effect called quantum tunneling to get past the barrier. Tunneling depends on the fact that down at the quantum level, where particles are a lot smaller than atoms, the world is a totally random place. When a particle like a photon is here, it also has a small but very real chance of being here, or here, or here at the other end of the barrier. What Nimtz and his team did was to pick up the photons that appeared at the far end, and then to measure how fast they got there.
Ja, du brauchst jetzt nicht ernst zu werden.
I'm amused about this. We did this for fun. And when we figured out that it's faster than the velocity of light, we did not think about its importance.
The leader in this field, Raymond Chow, has misgivings about Nimtz's interpretations, but even he agrees with part of what Nimtz is saying.
In our experiments, we have measured that a single photon can tunnel across a tunnel barrier at 1.7 times the speed of light.
Right or wrong, this leads to an interesting thought experiment, a Gedanken experiment in German. What if you could tunnel a message to the other side of the universe? Going faster than light, the message would seem to go backwards in time.
I came across a nice Gedanken experiment. There's a signal going to a far star, which is information that you were born. And 20 years later, tunnel the signal at your age of 20 years, and this will arrive before the signal comes to the star that you were born.
Yes, if we had a tunnel barrier that was, say, very wide from here to the next galaxy, then in principle, yes, you could then, in the tunnel effect, advance the wave so much so that it begins to worry me that we have sent something really fast in the speed of light.
I insist on it that we have and we can transmit signals faster than the velocity of light.
Perhaps one day our infinitely advanced grandchildren will send messages back through time, or even use wormholes to travel back comfortably themselves. But that leaves one big question.
Time travel might be possible, but if that is the case, why haven't we been overrun by tourists from the future?
This argument I find very dubious. It might be that time travel into the past is possible, but they haven't gotten to our time yet. They're very far in the future, and it's the further back in time you go, the more expensive it is. Then there's a possibility that they're here all right, but we don't see them. They have perfect invisibility cloaked.
The question. Phone now 0900 92 333 or teletext page 333.
Missed the lotto numbers? Want to check the latest lotto results?
Hello, Lindsay Coleman speaking.
Hello, Lindsay. This is Jeremy.
Hey, how you doing?
Not bad, thanks.
Oh, it's good to hear. Good to hear from you.
Yeah, I was going to call you ages and ages ago.
Oh, that's all right. No worries.
It just takes me ages to get around to doing things.
Yeah, I know. How you doing?
Well, seems always.
Yeah?
Yeah, not too bad.
Yeah, anything interesting happened lately?
No, I lost my license. Nothing seems to happen.
Oh, that's all right. You'll get another one.
Yeah.
Eventually.
5 months, yeah.
Oh,
I've got to wait.
Yeah, I'm sorry, huh? Did you have to go into court?
Yeah.
Yeah? Were your parents there?
No, my father came, yeah.
Oh, was he all right?
He wasn't very happy about it.
But was it okay?
Yeah.
He didn't bring out his belt or anything?
No.
I know some fathers who would do that regardless, man. You would not believe it.
Yeah.
Oh, but it's all right, man. He's probably relieved. He's probably like, oh, thank God, he did something wrong.
Yeah, because I've been such an angel all my life.
Yeah. Yeah, you know, Anna's trying to get us all back together again.
Anna?
Yeah.
Yeah, she just wants us to be one big happy family.
I know.
Yeah.
You reckon we could do it?
But you, me, and Anna?
Yeah.
Yeah, that'd be right as long as
yeah. You wouldn't mind?
Yeah. Just don't bring anyone like Kelly or Scott into it. Yeah.
Oh, yeah. You know, I hardly know any of these people, man.
Yeah, yeah.
Well, I hardly know any of them.
You don't know Kelly very well, do you?
You think her obsession has ended?
Anna?
Yeah.
Obsession?
Yeah, you know.
Which one?
With, what's his name?
Hayden.
Hayden, yeah.
She still goes on about it a bit.
Oh, shit. Listen, I have to go to work right now.
Right now.
But, I'll just go get a pen.
Yep.
And I'll get your number, and I'll call you tonight. Does that sound all right?
Yeah, that sounds right. I'll be home tonight.
Okay, one sec. All right, let's hear it.
Okay, 413.
413.
83.
83.
53.
53.
Yeah.
Fantastic. You're over in Albany, right?
Yeah, Albany, yeah.
Oh, great. Listen, I had a great time that day we went out.
Yeah?
Yeah. And I want to meet with
up,
you guys.
Up to the time when I got arrested.
That was okay. That was better, man. That was interesting.
Well, for you maybe, because you're the one watching. When you're the one being arrested, it's not that great.
Yeah.
It's pretty terrible when you get to the station because it's really weird being treated like a criminal.
Yeah, how did they treat you? What were they like?
Well, they didn't sort of touch or anything, but they talk to you as if you'd, as if...
That's just the cop manner, you know?
Yeah.
That's the